Black holes are supposed to be the one thing nothing can destroy. Scientists just prove that's wrong. They're dying. Right now. One photon at a time. Here's the problem. Nothing is supposed to escape a black hole. Not light. Not matter. Not information. That's the whole definition. A point of no return. But in 1974, a physicist named Stephen Hawking found a loophole. Not in a black hole. In empty space itself. Space isn't actually empty. Down at the smallest scale, it's boiling with pairs of particles, popping into existence, then instantly destroying each other. It happens everywhere, all the time, and it cancels out to nothing, except at the edge of a black hole. Right at that boundary, the event horizon, one of those particle pairs can get split in two. One falls in, the other escapes. To anyone watching from outside, it looks like the black hole just emitted something. Radiation, leaking out from the one place radiation shouldn't exist. That's Hawking radiation. And here's why it matters. Every time this happens, the black hole loses a tiny sliver of mass. It's not gaining, it's spending. Now here's the part that breaks people's brains. You think a bigger black hole loses mass faster, right? More surface, more leaking? It's the opposite. Bigger black holes evaporate slower. Smaller ones evaporate faster. And the smaller they get, the faster it happens. Which means a black hole's death isn't a slow fade. It's a countdown that accelerates. For a black hole the mass of our sun, that countdown is longer than the current age of the universe. By a factor of a billion trillion 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 trillion. We're talking numbers with no real intuition attached to them at all. But it will happen. Given enough time, every black hole in existence, from the ones we can barely detect to the supermassive giants sitting at the center galaxies, will shrink down to nothing. And in the final seconds, that slow leak turns violent. As a black hole gets smaller, it gets hotter. And as it gets hotter, it radiates faster. It spirals into a runaway process and ends in a final, blinding burst of energy. Its last moment is an explosion, which brings us to the strangest part of all. Stars will burn out. Galaxies will drift apart. Light itself will stretch until it fades to nothing. But black holes will still be standing, long after everything else in the universe has gone dark. They'll be the last objects left, the final things still existing in an otherwise empty cosmos. And then, one by one, they'll flicker out too. Nothing lasts forever. Not stars. Not galaxies. Not even the thing that was supposed to be inescapable. If this rewired how you think about the universe, follow for more, because this is only the beginning of how it all ends.